Hello, this is Kavya and Ashwath, and this is our proposal for ARM Manipulator Motion Path Planning IK Solver for Acme Robotics. The ARM Manipulator can be used for automating menial tasks and also to some extent replace a human arm. The main three modules of this project are the IK Solver, the Path Planner, and the Simulator. So the final deliverables will be a C++ package which the user needs to install in its environment. The code needs to be run with an input of the goal end effector positions, and the output will be a simulated trajectory on a virtual environment.
So we are using STOMP as a main trajectory planning algorithm. STOMP stands for Stochastic Trajectory Optimization for Motion Planning. STOMP uses two main cores for making the trajectory. The first one is obstacle, and the second one is randomly generating the trajectory and then converging on a most suitable based on the smoothness of the trajectory. So there are three main testing methods. The first one is checking if the output is with C space, and the forward kinematics. Forward kinematics is to check if the arm is reaching the correct goal state. And the third one is the simulation. That is to check if visually check if the whole trajectory is being followed properly. So these are the technologies that we're using. Our main implementation is with C++ object-oriented programming paradigm. We're using CPP-lint as a design guideline, and there are three main robotic software packages that we're using, which is MoveIt, OMPL, and Eigen C++ library. Coppola Sim is our simulation environment.
So the implementation will be done using pair programming. There will be a driver and a navigator. As the driver codes, the navigator will inspect, which will result in a bug-free and robust product. These rules will be switched subsequently between submodules. Also, we are using Git for code maintenance. The standard agile methodologies will be used, which will ensure a very flexible and adaptive approach to the problem, and we can change the plan real time as per the changes in the system.
So the risks involved in our project are divided in two main categories. The first one is development cycle, and the second one is deploying in real world. So in development cycle, we need to account for the time taken for calculation of joint angles and torque. And for deploying in real world, the main challenges will be the time sampling will be large in our implementation, and real world will also contain a lot of noise. The ways in which we could mitigate these problems is by testing each modules and validating in real world, and you can also change around the RL tolerance and fine tune it for the real world.